My name is Mr. Mörlin. I work for a company called Wavetrain Systems. We are from Norway. This started originally as an idea with two engineers regarding seismic. Norway is big in oil and gas, and seismic is part of that. So the initial idea was to place a seismic reader close to the railway. But the Norwegian railway authorities were so interested in this, so they actually said, well, why don't you please mount it on the rail so we can get a proper reading. So this is how it all started in 2009, and then this has evolved. So it has been on a trial basis in Norway. It's been trialed on 4 continents in total, with 4.5 million train passings, and now has a type approval in the UK, and we're expanding. So we're actually, people are calling us to learn more about the system and how we can reduce risk at level crossings worldwide.
So in the beginning it was another issue, not the level crossings, but general other safety questions.
They had an idea of how to sniffing the rail as a whole. So of course when you listen to the rail, you can find all sorts of things, not only to reduce risk at level crossings, but there can be broken rail issues, there can be other stuff, there can be infrastructure or operator issues. So the system has a certain flexibility, and it can expand into other features as well.
So now the level crossings, perhaps you may show the 2 systems that we see here presented. What is the standard one, what we know of, and what is your offer?
The classic offer is what we call a conventional system, which is a conventional system with a treadle, a striking point, and you have this is a visualization of a level crossing. And in this case, for example, if you have a speed at the level at the rail, which is 80 kilometers an hour, and you want a 30-second warning time, you need to drench 660 meters that way for the entry point, and then a strikeout point which goes 660 meters the other way, as long as the traffic goes both ways. And of course, as long as the line speed is upheld, but if there is a cargo train coming, for example, and that only runs at 40 kilometers an hour, means that you have a 60-second warning time. And this is where the human factor plays in, and it might be problematic because people expect it to be 30 seconds, or they have learned that it's 30 seconds, and suddenly it's longer, and then they might walk. And that is where the accidents might happen. So our whole mission is to reduce risk at unprotected level crossings by installing a sensor at the level crossing. So as long as the rail is welded continuously, we will hear the train far, far away, 5, 6, maybe even 7 kilometers away. We can hear the train coming, and then we, based on the algorithms and the variables we have, we can then adjust the warning time to local requirements. So when it comes mixed traffic, one slow, one fast, one slow train, that is no problem with us. We will still have a concentrated number of warning times for passing.
Do you have to install anything on board of the train?
No, only a sensor here and the small control cabinet, nothing on the train. And we're not connected to the signaling system, we're fully autonomous. So this is a standalone system that works perfectly on its own. So it's basically fit and forget.
And how do you transfer the signal? Is it GPS or 5G or whatsoever? Cables?
This is cabling. So yeah, because very few type approvals. There are some, but when it comes to wireless, it's often more complicated. So we have stuck to cabling. In Australia there might be a difference when we look into that market or other markets, but for the moment we have cabling.
Acoustic detection, do you see any obstacles possible? So someone is suddenly doing any kind of noise nearby the track that might be misinterpreted? Passing vehicles or rain or whatever that can hail, for example,
that can cause the rail to have a different sound, that is no problem. Of course, if you have trackside working with a pneumatic drill, that would give a strikeout on our measurement, but it's still not, it doesn't look like a train. So the system has sort of learned itself that when a train is coming, it's a certain type of level. So any type of work that is done on the side is off scope, as we say. And usually when you do trackside work, there are other measurements taken as well when it comes to safety.
Do you have measurements against kind of grease or some sabotage? Someone would put some glue on top of your... And nowadays you never know.
It looks like this. This is the sensor we're talking about. It's that small. And then we have added a clamp. This is primarily for tampering and theft reasons. So grease or glue or cold or ice or anything around this, in Norway, parts of the year, this whole system is covered in ice, blue ice basically. That is of no problem, since we are listening to the rail itself. But this has been added for tampering and stealing and theft. So especially in the UK, there is an enormous problem with people stealing cables, and this reduces that risk significantly.
So you don't see any problem that it might get harmed or so?
No. We haven't, during all these passings and all these years of trial, we have seen no problems with that.
Usually when nowadays talks as well on redundancy, so do you have two detectors perhaps in the one, in case one would not work, so that you it is the same what one does nowadays with the ETCS and so on, so that you check that those signals are the same ones also?
We have 4 sensors in total, 2 per rail. So if we would have a 2-track system, then we would have 8 sensors. 2 plus 2 plus 2 plus 2 for redundancy. Same inside the cabinet. We also have double up of everything due to the redundancy and safety.
So it seems you have thought of all possible questions that might occur. So how it runs now on the certification side?
In UK now, we have had the type approval for the train detection part since 2022. And now we are getting a system approval for the whole system, because this is of course connected by local regulations to local lights and sounder. So in UK now we're getting a type approval for not only the train detection part, which is sort of the gold here, but also the physical part when it comes to the pole with the lights and sounder. So that is being done, I would say, before end of May, early June. We have that as well. So then we can start installing systems all over UK, as long as the local level crossing managers want it, of course, to reduce it.
But this is in case you don't have any barriers going down.
It can be, of course, you can add barriers as well, but the whole beauty with this system is that we are to take all those level crossings that are unprotected out in the rural areas, and you only then need, most probably, to add lights and sounder.
And in Germany, one would say up to 160 kilometers per hour, it is allowed to still have those level crossings. If it's faster, then not. So, what is your information on other countries?
We have evidence that it's working perfectly up to 125 miles per hour. So that would cover your yes.
So it might be a chance to save money for those who intend to modernize or reopen abandoned lines to bring them on to the best achievable level without paying too big sums.
We look at this as a very good way of upgrading old equipment or non-existing equipment to get today's safety standards.
Which which countries would you like to offer this? Great Britain, I understand you are already on the way to settle this.
We are, of course, in UK there's a high interest and a high attraction for our product, and there are loads of level crossings that needs taken care of. But I mean, this could be doable in both France, if we think locally. I mean, Norway is of course our home market. Sweden as well is interesting. But all the big markets where there are loads of unprotected level crossings, and it takes an awful amount of time and money to try to upgrade them in the conventional way. They are all interested. And also ARTC in Australia, we have a good dialogue with now. So we have been trialing in Australia before, and now they have a strategy and a plan for reducing level crossings or leveling them up to today's standard. So we have a dialogue with them as well. So we're also going to the International Level Crossing Awareness Day in Buenos Aires this year, to present this system, more to show them the innovation and what can be done at an affordable price. Instead of using vast amount of money for maybe 1 or 2 level crossings per year, you can then have numerous level crossings being upgraded for this system.
And what about Poland? I think there are 4,500 level crossings that need a solution. Unfortunately, they have very bad, risky drivers. These drivers, especially on trucks, they don't believe that something will come because they think they are so strong.
Okay.
When they see that they are not so strong because the train was coming, then often it's too late.
Okay. Well, I don't know about the Polish drivers.
You should have, I mean, like Star Wars, in the train, a laser light signaler. So
all I know is that. All I know is that we're at IoT now in Cologne, and I haven't. Of all the countries I've talked to, they've all been interested. But it's of course down to where are you in the process and how do you accept a type approval from another country. So I know for a fact that since we've done a lot of the documentation in UK, for many other countries, then the documentation material is already taken care of. So it might be a much faster process to incorporate in other countries as well.
For me, an argument might be that what I have seen several times in countries like Poland, that this cable is getting stolen and then it doesn't work at all.
Exactly.
So this is in countries where cable are stolen often, and where you have so many level crossings, like for example in Poland, where you can run around the country and each day take the cables away, and when there are new ones, you take them away again. So this is absolutely risky. This is, from that point of view, I think much better, because you can't steal anything. There is nothing inside in the ground.
There's nothing mechanical, and again, the only thing you then can tamper with or try to steal is this sensor, and it's mounted to the clamp with 200 Newton meters.
That even would not help for 1 bottle of vodka, because it's no copper. So
exactly.
I would not touch it.
It's a standard signal cable, so there's very little copper inside.
So I wish you all the best, and hope you will sell it in countries wherever possible, because it seems to be quite interesting system and worth being promoted.
We think so as well. Thanks for taking your time.
Yeah, thank you.
Excellent. Bye-bye.